Hi everyone. In today's session, we are going to discuss about the flowchart sequencing, in that a model of processing of n jobs through two emissions. So in that also the problems are of different cases are there. In this session, we are going to discuss about a problem of maximization case type. So let us see the problem, how it is different from the different models, and without any waiting, let us get into the solving of that type of problem. So here it is the problem. Mr. Shyam receives 10 rupees per hour of processing the jobs. Every job has to undergo two operations, machining and polishing. The time estimates for 4 jobs to be processed in this week are given below. What should be the sequence if he intentionally delays his jobs by maximizing the idle time of operators so as to maximize his returns? And what is the amount that he can gain or lose as compared to that had to be processed with minimum delay? So, and these are the 4 jobs we need to process. Those are P, Q, R and S. So, and the 2 machining processes are machining. The 2 undergoing operations are machining and publishing. Sorry, it is not publishing, uh, polishing. The polishing process, these are the 2 operations and their time estimates were given in terms of hours are given there. Now he is asking us to find what is the amount that he can gain or lose as compared to that had to be processed with a minimum delay. So here the Shyam can form a sequence of jobs that maximum idle time of missions can get, so that he can earn either profit or loss. And if he sequence the jobs in such a way that if the idle time of the machines is less, then he is asking us to find the difference, amount difference between the maximization case and minimization case. So it is a different model as compared to the previous ones. So now let us first of all solve the problem in a maximization case of type. Okay, so in any way, for forming the sequence of the jobs, we are going to use the Johnson's algorithm, and that is the only one we are having in order to form the sequence of the jobs. So here I am going to solve the problem first in a maximization case type. So let us see here. First of all, we need to form the sequence in a maximization case type. Okay, and now this is the data given to us, and now we need to first of all identify the sequence of the jobs. So totally here 4 jobs are there, so that's why we need to draw a table with single row and 4 columns. So here I am drawing the table with single row and 4 columns. So now let us sequence in a maximization case type. If you want to do the sequence in a maximization case type, then every time we need to identify the maximum value in the time estimates, and if that maximum value is present in the first process, then we need to write that in the left side of the table, or otherwise we need to write it on the right side of the table. Okay, so now let us see. So in the 8 values of time estimates, what is the maximum value? the maximum value is 45 and that is corresponding to the job Q and which is present on the machine on the process of machining, that is on the first process. So that's why we need to write Q on the left side of the table. So now I am writing Q on the left side of the table and then strike off the Q value here. And next, if you see the remaining 6 values 10, 20, 25, 35, 40 and 30, the maximum value is 40 and that 40 is corresponding to the job R and it is on the second process polishing. So that's why we need to write the job R on the right side of the table. So here I am writing the R on the right side of the table and then strike off the R. And next, in the remaining 4 values, the maximum value is 35 and it is corresponding to the job P and which is present on the second process. So that's why we need to write P on the right side of these two grids. So in these two grids, the right side is this one. So that's why here I am writing P. Strike off P here. So the remaining one job is only S. So that's why fill this grid with the S. So now the sequence is Q, S, P, R. So now we need to find the total elapsed time and the idling time of the machines if we follow this sequence. So now I am going to write the sequence first of all. QS PR and this is our regular table. Sequence, machining, in time, process time, out time. For polishing also in time, process time, out time, idle time for machining and polishing. So first of all, let us write the process times in each operation. So first, corresponding to Q, the process times are 45 and 15. So write them 45 and 15. And next, the next job is S. The process times are for S 25, 30. So write them 25, 30. And next, corresponding to job P, the process times are 10, 35. So write them 10, 35. And next, corresponding to the job R, the process times are 20, 40. So write them 20, 40. And next, let us find the total elapsed time. First, in time is 0, already we know. The first job requires 45 hours in order to complete the machining process. So out time will be 45. Then immediately the job S will enter into machining process. So the in time is 45 and the job S requires 25 hours of time for complete the machining. Then out time will be 45 plus 25 is equals to 70. So in a similar way, job P in time will be 70 and the out time is equals to 70 plus 10, 80. And then for job R, the in time will be 80 and the out time is 80 plus 20, 100. So now for the machining process, we have completed the in times and out times. So now let us find the in times and out times in the polishing process. So After completing the machining process for job Q, immediately it will enter into polishing process. So job Q completes the machining in 45th hour. So the in time for polishing process is 45th hour only. Then out time will be 45 plus 15, 60 hours. And then the job S will enter into polishing process at 70th hour. Why? Because means job S completes the machining process 70th hour only. But at the 60th hour itself, job Q completes the polishing. But at the 60th hour, the job S can't go to polishing. Why? Because means it completes the machining at 70 hour only. So in the maximum of 70 and 60, we need to write the maximum value here. So now the out time will be 70 plus 30, 100. And next, corresponding to job P, the maximum value of 80 and 100, 100. The out time will be 100 plus 35, 135. And next, for corresponding to job R, the in time will be the maximum of 100 and 135, that is 135. The out time will be 135 plus 40 is equals to 175. So like that, we have calculated the in times and out times. Now what is the total elapsed time in the sequence? It is equals to 175 hours. So now let us calculate the idle times. So in machining process, idle times, initially job Q enters at 0th hour only, so there is no idle time, 0. That's why it is 0. Next, idle time, difference of 45 and 45, 0. Next idle time, difference of 70, 70, 0. Next difference of 80 and 80, 0. And the final difference in out times, 100 and 175, the difference is 75. So then what is the total idle time in machining? 0 plus 0 plus 0 plus 0 plus 75. So total idle time will be 75 hours in machining. Next, let us calculate the total idle time in polishing. So the polishing process started at 45th hour. So up to that time polishing machine has to be idle. So that's why idle time here will be 45 hours. And next, corresponding next to the jobs, the difference between 70 and 60, 10. Next, difference between 100 and 100, 0. Difference between 135, 135, 0. Then what is the total idle time? 45 plus 10 is equals to plus 0 plus 0 is equals to 55. 55 hours of idle time in the polishing. Then what is the total idle time? So total idle time is equals to 130 hours. Total elapsed time is 175 hours. Total idle time is 130 hours. So this is the case. These are the values in a maximization case. So now let us find the sequence if in minimization case. So let us solve it. So now we are going to find the sequence in a minimization case. So here we are having the 4 jobs. So that's why draw a table with a single row and 4 columns, 1, 2, 3 and 4. So now let us find the sequence in a minimization case. So now it is our regular procedure. So first of all, identify the minimum value in these 8 time estimates. So what is the minimum value? So minimum value is 10 and that is regarding to the job P and which is present in first process. So that's why write P on the left side of the table, P. So strike off P now, and then what is the next minimum value in the remaining 6 time estimates? The minimum value is 15. that is corresponding to the job Q and which is present on the second process. So that's why write Q on the right side of the remaining grids. So in these three grids, the right side is this one. So that's why I am writing Q here. So now strike off Q and then identify the minimum value in the remaining 4 time estimates. So the minimum value is 20. It is corresponding to the job R and which is present on the first process. So that's why write R on the left side of the grids. So these are the 2 remaining grids. So what is left side? This one. So here I am writing R. So now strike off R. So what is the remaining job? Yes. So that's why write S in the remaining grid. So now what is the sequence? P, R, S, Q. So now write that sequence in the table. P, R, S, Q. So now let us write the process times. First for P, the process times are 10, 35. So write them 10, 35. And next for job R, the process times are 20, 40, 20, 40. And next for job S, the process times are 25, 30, 25, 30. And for job Q, the process times are 45, 15. So write them 45 and 15. So now let us calculate the in times and out times in both the process and also the idle times. So first in time will be 0 and out time will be 0 plus 10, 10. And then the in time for job R is 10, out time will be 10 plus 20, 30. And in time for job S is 30 and out time will be 30 plus 25, 55. And then for job Q, the in time is 55 and out time is 55 plus 45, 100. And next, coming to the polishing process, the in time will be, so job P, out time is 10 and immediately it enters into polishing. So the in time will be 10 hours and the out time will be 10 plus 35, 45 hours. And next, for job R, in time in polishing is the maximum of these two, 30 and 45. So maximum is 45. So then out time will be 45 plus 40, 85. Next, the out in time for job S in polishing is maximum of 55 and 85. It is 85. Then out time will be 85 plus 30. It is equals to 115. And next for coming to job Q, the in time is maximum of 100 and 115. It is 115 and out time is 115 plus 15, 130. And then let us calculate the idle times in both the processes. So the idle time in machining is equals to initial idle time 0 and next idle time difference of 10 and 10, 0, difference of 30, 30, 0, difference of 55, 55, 0, and next final times difference of 130 and 100, it is 30 hours. Then what is the total idle time? Total idle time will be 0 plus 0 plus 0 plus 0 plus 30. It is equals to 30 hours. And next let us calculate the idle time in polishing. In polishing, total idle times are initially the polishing machine has to wait for 10 hours. So the idle time is 10. And next idle time difference of 45 and 45, 0, difference of 85 and 85, 0, difference of 115 and 115, 0. Then what is the total idle time? So total idle time is 10 plus 0 plus 0 plus 0. So final 10. Then what is the total idle time? Is equals to 30 plus 10, 40 hours. And what is the total elapsed time? 130 hours. So if you take the minimization case, the total elapsed time is 130 hours and the total idle time is only 40 hours. So this is the minimum idle time. And in the maximization case, we have got the maximum idle time. Now he is asking us to find what is the difference. What is the amount that he can gain or lose as compared to the he had to be processed with minimum delay. So if he delays more, then whether he can get gain or loss, and if he gets the gain, how much he will get the gain. He is asking that one. So now let us find that one. So in order to find that one, simply here I have formed a table. So the table is this one: job, total elapsed time of each job in maximization case and minimization case, and next returns at 10 rupees per hour. So in the problem itself, the data is given. Mr. Sham receives 10 rupees per hour of processing the jobs. So that's why here I have written returns at 10 rupees per hour in maximization case and minimization case. And next the difference amount we will calculate. So let us see what is the amount. He can get the difference whether it is a gain or loss. Okay, so first of all, how many jobs we have? 4 jobs we have. So the jobs are P, Q, R and S. So now let us see the maximization case, total elapsed times. So in maximization case, the total elapsed times are, see here. So this one is the maximization case. The total elapsed times for P. For P job, the out time, the job P completes the 2 processes by 135th hour. Then the total elapsed time for job P will be 135. For job Q is 60. For job R is 175. For job S is 100. So that means by those hours that job is going to complete the 2 operations on that. So now write those total elapsed times for each job in a maximization case. So those are 135, 60, 175 and 100. So I am writing those values: 135, 60, 175 and for S is 100 hours. And next let us write the total elapsed times of each job in minimization case. So now in a minimization case, the total elapsed times are for job P is 45. So by 45th hour it completes both machining and polishing process. For job Q 130, for job R 85, for job S 115. So let us write those values here in a minimization case. So for job P 45, for job Q 130, for job R 85, for job S 115. So now let us calculate the amounts returns. So job P is completed by 135th hour. So 135 hours of time it will take to complete the two processes for job P. Then what is the amount he will charge? Then one for each hour he will get 10 rupees. Then totally how many hours he is working in maximization case on job P? 135 hours. So the amount will be 135 into 10, that equals to 1350. Next, similarly, job Q, in a maximization case, he is working 60 by 60 hours. The job Q two operations were completed. Then he will charge 60 into 10. Totally 600 rupees he will charge for job Q. Then for job R is equals to 175 into 10, that is 1750. And next, job S, he is going to charge and he is working 100 hours on job S. Each hour he is charging 10 rupees. Then the amount he will spend, he will get for job S is 100 into 10, 1000 rupees. So similarly, in a minimization case, how much amount he will get? So the job P is completed by 45th hour itself. So the job P is completed by 40, that means he is taking 45 hours of time to complete job P. Then the amount he will charge is for each hour 10 rupees. For 45 hours, 45 into 10, that is 450. Similarly, 130 into 10, 1300, 85 into 10, 850. Next, 115 into 10, 1150. So these are the amounts he is going to charge for each job in a minimization case. Okay. Now let us see, in a maximization case, 1350 rupees he will charge for job P, and for 450 rupees only he will charge for job P in a minimization case. So then what is the difference amount? 1350 minus 450, that is 900 rupees. So that means if he delays more, if the Shamis delays more means it is a maximization case. Delay is less means it is minimization case. If Sham delays more, or that means if he get the idle time of the missions more for job P, then he is going to get a gain of 900 rupees for job P only. Similarly, for job Q, the difference in a maximization case is 600 rupees only he will get. But if you take in minimization case, for job Q he will get 1300 rupees. What is difference? 600 minus 1300, that is minus 700. That means for job Q he is going to lose 700 rupees. In a job P he will gain 900, but in job Q he will lose 700 rupees. Similarly, let us calculate for job R. So in job R, in a maximization case he is getting 1750. In a minimization case he will get only 850. So then what is the difference amount? 900 rupees he is going to gain if he delays more. And next, coming to job S, he is going to get for job S 1000 rupees in a maximization case, but in a minimization case he is going to get 1150. So then what is the difference? 1000 minus 1150, it is minus 150. That means he is getting loss of 150 rupees for job S. So that means if Sham is delaying more, then he will gain a 900 rupees on job P. He is going to lose 700 rupees on job Q. He is going to gain 900 rupees on job R, and he is going to lose 150 rupees on job S. So let us find the total difference on these four jobs. Now let us find the total difference. So total difference is equals to 900 minus 700 plus 900 minus 150. then the value is equals to plus 950. That means Sham is going to gain an amount of 950 rupees 950 rupees if he delays more, if he intentionally delays such that the idling time of the machines is increasing, and so that in order to complete the 4 jobs, by the completion of 4 jobs, Sham is going to gain an extra amount of 950 rupees. So by understanding this problem, now you can get, or you can know the importance of sequence. If you do the sequence in a proper way such that the idling time of the machines is less, then you are going to spend only less amount in order to complete the 2 operations. When the idling time of the machines is more, then we are going to spend more amount on the for completion of the 4 jobs, 2 processes, right? So like this, in a maximization case, we are going to solve the problems, right? So totally we have seen 4 cases of models in a type of processing of n jobs through 2 missions. So in previous cases itself, I have solved the previous models. So in first case, I have solved there is no tie of time estimates in both the series. And next case, I have solved ties in the same series. And in third case, multiple solutions. And in fourth case, I have solved the maximization case of problem. If you did not watch those videos, I am going to leave those videos in the cards session. So you please go through that and watch it carefully. So with this, we have completed the sequencing, that is flowchart sequencing, processing of n jobs through 2 missions. So in the next session, we are going to see the processing of n jobs through 3 missions. So I hope you understand the solving of this problem. If you understand, please like this video and also share and subscribe to the channel. Thank you.